Hey everyone, so these notes are on the ideal gas law. I'm going to go through the notes with you, go through 3 problems, and then you're going to try the rest of them on your own. Okay, so the ideal gas law talks about ideal gases, and ideal gases have no mass, so they don't weigh anything. They're also not attracted to each other. So this scenario is actually really difficult to find. It's not often that you'll see an ideal gas because it means that that gas is perfect. Everything about it is absolutely perfect, which isn't always true. But if it were perfect, we can use this equation to predict the pressure, volume, moles, and temperature of it. Okay. Ideal gases typically exist if we have high temperature and if we have low pressure. All right. So here is the equation. It is PV equals nRT. Okay. Now to define the parts, P is pressure, and it has to match something called the R constant. So if you look at a reference table on the very front page of it, there's this section that you'll see called gas constant R, and you're going to see 3 different numbers, 1, 2, 3. Okay, so the 3 different numbers, the only thing different about them is this pressure right here. So this number, 0.0821, goes with the pressure ATM, which is atmosphere. 62.4 goes with mmHg pressure, and then 8.314 goes with kPa pressure. Okay, so that's PV, volume has to be in liters. Remember, if it's in milliliters, then you are going to divide by 1,000 to get to your liters. All right. N in this case represents the number of moles. So remember in class, we've converted to moles before. Moles. Okay. R is a constant which is found on the page 1 of reference table. That's this gas constant R that I just talked about. And then T is temperature. That temperature has to be in Kelvin. So remember, if it's in Celsius, then we're going to add 273, and then we're going to get it in Kelvin. So this equation is already on your reference table. You can find it here, PV equals nRT, and then you can find the definition of the abbreviations on the right-hand side. So let's take a moment to read this first problem. We have 685 liters. Well, that's volume. 62K. Well, that is temperature, and it's actually already in Kelvin. That's a good thing. Pressure is 1890 kPa, so that is P. The question is how many moles? So you're finding N. So I'm going to take this equation and I'm just going to plug stuff in. So I know my pressure is 1890. I know my volume is 685 equals N is something I don't know because the question says how many moles. So it's just N. The way I'm going to figure out the letter R is, remember, the front page of your reference table has this gas constant R. Okay. Now, if you look, the pressure is in this unit called kPa. So I'm going to look at these and I'm going to find the number that goes with kPa, being that number right there, which is 8.314. So 8.314. And then T is temperature, 62 is my temperature. Okay. Now to solve and get N by itself, I'm just going to divide both sides by the 8.314 and the 62. This cancels that out, You're dividing both sides by it. So this is how your setup should look. And then your N should equal that many moles, a very large number of moles. Okay. Next problem, what volume will 12.0 moles? So here we have the N occupy at 25 degrees Celsius. So this is T, but the T is not in the correct unit. So add 273 and you should get 298 if you add 273 plus 25. And then the pressure is 52.7 kPa. So that's P for pressure. Okay, so I've got my equation. I'm going to do PV equals nRT and plug stuff in. P is 52.7. V volume, I actually don't know that because the question says what volume. So it's just the letter V. Equals N is moles. That's 12.0. The R, remember that you have to look at the front page of the reference table. This pressure is in kPa, so I'm going to look kPa. This says gas constant R. The kPa is right here. The number that goes with it is 8.314. So I plug in 8.314. T is temperature, that's 298. And then to solve and get V by itself, you're just going to multiply and divide. So divide both sides by the 52.7 so that this cancels out. And then the answer that you are left with is a volume of 564.15 liters. Okay, try to do the next one yourself and then watch the video to see if you do it correctly. Next one, you also have the moles. So this is N. You have the pressure, that's 0.600 atm, that's a P. The volume is 30 liters. That's V. What is its temperature? So here it's asking you to find T, temperature. So I'm going to plug stuff in. The pressure is 0.600. The volume is 30.0 liters. I know the N is moles, and that's 0.800. The R, I'm going to check with my reference table, and this pressure is in ATM. Okay, the pressure in the question is in ATM. And if I look at the choices, the gas constant R section, the ATM number is 0.0821. And then temperature is what I'm trying to find, so I don't know that part. You're going to divide to get temperature by itself. Divide both sides by that 0.800, so that cancels out, and the 0.821, that cancels out, and you're left with solving for temperature. Your final answer should be 274.06, and because it's in temperature, it is in Kelvin as your unit. All right, that's as difficult as some of these problems will get. Try them yourself, and then make sure that you eventually finish the entire paper by the end of class. Turn in the note sheet.